Welcome to our BreakMate service training session. I'm Carlos Zellner, Executive Vice President of BreakTime Enterprises, and with me today are Dick Miller, our Technical Director, and George Swift, the Technical Services Manager for BreakTime. We wish we could be out there with you conducting this session in your shop, but instead this video will allow us to take you through the basic servicing and repair of the BreakMate and its accessories. While it's a fact that the BreakMate is the most reliable piece of post-mix equipment ever made, it's not perfect, and when it comes time to repair it, we want you to know how. We will divide our video into sections covering the basic operating principles of the BreakMate. This includes troubleshooting, repair procedures, accessory installation and repair, and finally warranty procedures along with parts ordering. It's a good idea to have your service manual handy for reference throughout this tape. I would like to begin by reviewing the basics of Level 1 service training. This includes bench testing of the BreakMate, proper installation, accessory attachment, key operator training, and CO2 filling. Let's begin with bench testing of the BreakMate. Bench testing the BreakMate. While we're going to be using this studio setting for our training session, you should have an area in your shop where you set up the BreakMate and check it out just prior to installation. Why? Well, there's several very important reasons. While out-of-the-box failures are rare with the BreakMate, checking the machine out before arrival at the outlet is the smart thing to do. There's another very important reason for bench testing. With all the functioning of the machine checked out, you can let the ice bank build in the carbonator so that when you install it within the next 10 or so hours, it'll be ready to go immediately after installation. In other words, your customers won't have to wait for ice-cold refreshment, and their first drink will be a good one, the kind the BreakMate will deliver time after time once it's up and going. So what do you have to have in your shop for preparing the BreakMate for installation? It's not complicated, not expensive. You need electrical outlets and a filtered water hookup for one or more machines. And you should remember to thoroughly flush your water filter when it's first installed in your bench testing setup. Proper bench testing includes the following steps. You remove the machine from the packing carton and check for visual damage. If everything's okay, the next step is to connect the filtered water line to the inlet valve on the back of the machine. Next step, you relieve the CO2 pressure from the carbonator by pushing in the red button inside the CO2 cylinder compartment. Hold the button in until all the gas is vented and the button stays in by itself. Occasionally you'll find a new machine with no pressure in the carbonator and the red button will already be pushed in. Usually this doesn't signify a problem, so you should proceed with the setup. The reason for venting the carbonator is important. Without CO2 pressure in the system, the water pump doesn't have to work too hard to fill the system with about 2 liters of water. In fact, if the pump will not pump if the pressure in the carbonator is at full force. Next step is to plug the BreakMate in and turn the power switch on by flipping it to the up position. The water pump will start and run for about 2 minutes and fill the carbonator with water. At this time, the top green light will be on, indicating that the power is on and that the machine is set for a small drink size, and the yellow CO2 light will be flashing. Once the carbonator has filled and the pump has stopped running, next step is to insert a CO2 cylinder, and the yellow light will go out and you'll hear gas entering the system. Now, sometimes with a new machine, the check ball in the CO2 regulator will stick and the machine will not readily accept CO2. Correcting this problem will be covered later in this video. At this time, the BreakMate should be given a minimum of 2 hours to build its ice bank in the carbonator and begin to cool down the syrup compartment. Remember, the refrigeration system will not switch over to the syrup compartment until the ice bank is built in the carbonator. Once the system is cooled down, now is the time to check for proper water delivery, syrup valve operation, and cooling of the water and syrup compartment. If a coin mech is to be attached, now is the time. It's very easy. Unpack the coin mech from the box and check for any visual damage. Remove the selector button panel from the front of the machine by removing the screw at the lower left-hand corner. Press up with your fingers at the lower right-hand side of the panel while gently pulling out with the left hand on the lower left-hand side of the panel. Next, loosen the two screws in the top of the control board and lift out the control board. Note that you do not have to completely remove the two screws. Thread the coin mech wiring harness through the hole in the right-hand corner of the back of the machine. Push it through along the side of the machine until it is visible in the front at the circuit board opening. There are 4 wires to connect with the 3 coin mech. 2 are plugged into the bottom of the circuit board. Two are plugged into the male and female connectors, which are attached to the circuit board wiring harness. With a single coin mech, or token coin mech, there is only one connection at the bottom of the circuit board. Now replace the circuit board and the flavor panel. The coin mech should now be attached to the BreakMate by removing the cover on the adhesive pad, putting the mech in place on the right-hand side of the machine, and attaching the metal straps which come with the coin mech. Once the coin mech is attached, the mech can be set for free vend or coin op by flipping the toggle switch located inside the coin box compartment. A second toggle switch changes the drink size. Remember, the drink size switch will not operate if the coin mech is set on free vend. If a coin mech is not attached to the BreakMate and a large size 10-ounce drink is desired, the gray jumper plug, which comes packed inside the syrup compartment with the inlet fitting, should be placed on the bottom of the circuit board. Setting the price on the 3 coin mech is easy. You should refer to your service manual for simple instructions. With a properly checked out BreakMate and an ice bank built in the carbonator, it is now time to install the machine in the outlet. To prepare for transporting, turn the BreakMate off, unplug the power cord and secure it, and disconnect the water line at the rear of the machine. The BreakMate should be secured in your vehicle when transporting and never turned on its side. A bench-tested BreakMate that has built a full ice bank can be installed up to 10 hours later and still have ice-cold water in the carbonator. A part of your installation tools should include an ice chest for cooling the first 3 liters of syrup when the machine is installed. This gives the customer a great drink from the very first. In the outlet, the BreakMate should be installed in a convenient, high-traffic location and as near a sink as possible. This is so daily maintaining and cleaning is made easy. The basic BreakMate installation kit includes a saddle valve for connecting to a water line, 3/8 inch OD tubing, and an inline water filter. In the outlet, connect the water line to the nearest cold water source. The length of the water line to the machine is not a consideration as long as the flow rate of the water is 4 quarts or more per minute at the machine. The water filter is installed in the water line at the rear of the BreakMate. It is very important that the water filter be thoroughly flushed before connecting the water line to the BreakMate. Run 2 or more gallons of water through the filter to remove the small carbon particles and activate the charcoal in the filter. Once the water line is connected and all the connections checked for leaks, the first liter of cold syrup should be installed along with the CO2 cylinder. You are now ready for key operator training. Key operator training is one of the most important parts of the BreakMate program. Properly trained key operators will result in higher customer satisfaction and, most importantly, fewer service calls. I suggest you use the key operator training checklist provided in your BreakMate training materials to ensure that all the key points are covered when training key operators. Let me highlight some of the key operator training points. Tell, show, and do. Tell the operator how to operate the machine, show them how to take care of the machine, and then let that key operator do what you have shown them. For example, daily maintenance of the machine. Show the operator how to take the drip tray out and how easily it comes apart into 2 pieces for cleaning. Show the operator that part of daily maintenance should be the rinsing of the drip mixing channel, which comes apart into 2 pieces. Show the changing of an empty CO2 cylinder. Vent the system so that the yellow light will come on to show them when the CO2 cylinder needs changing. Make sure that the key operator places the CO2 cylinder in and out several times themselves until they're comfortable with the process. Also show them the key points of changing a syrup leader. Use both hands to remove the mixing channel. Take the empty syrup cartridge out. Peel the foil seal from the top of the new liter of syrup. Explain to them the importance of keeping the next liter of syrup refrigerated if at all possible. To gently place the doser on top of the liter of syrup and turn sharply to the right until you hear 2 clicks. Never press down on the syrup valve. Then quickly turn the syrup leader over and put it back in place, which is identified by the label on the syrup compartment door, and then replace the mixing channel. Explain to the key operators that there is a troubleshooting guide on the syrup compartment door and that basic operating instructions are included on the right-hand side of the syrup compartment door. And finally, show the key operator where you have put your service phone number on the machine. Well, those are the highlights of the key operator training. Remember, tell, show, and let them do. We've told you that the BreakMate is a technologically superior piece of equipment, and yet it's simple to operate. Troubleshooting, which we will cover in depth later on, is made simple with a built-in diagnostic testing system. Let me demonstrate how it works. First, you remove the flavor panel from the front of the machine. On the back of the flavor panel is the test program sequence, which tells you how to put the machine into the test mode and how to make it perform its various functions. The first step in placing the machine into a test mode is to turn the power switch off. Next step is to push the 4th button from the top on the circuit board, and while holding that button in, turn the machine back on. At this point, the three lights, green lights, will start blinking in sequence, indicating that the machine is ready to be put into the test mode. However, since we're going to be making the machine perform various functions by pushing buttons and combinations of buttons, we need to make certain that the switches themselves are functioning properly. In order to test the switch, we simply press the switch in, and if all three lights stop sequencing and stay on solid, then that means that that switch is operating properly. So we go down the panel, check all the switches, and then we hit the bottom switch twice. The machine is now ready to be tested and to test every electrical component in the machine without removing any more covers or screws or anything from the machine. Give you an example, button 3 activates the doser coil in the sprite slot. So as I push button 3, the doser coil activates, indicating that this coil is functioning properly. Buttons 4 and 2 activate the outlet valve. As you see, the electrical outlet valve is operating properly and the water comes down the mixing channel. Button 4 and 1 test the electric water pump. And we hear the water pump come on, which is an indication that everything is fine with the water pump. You can check all electrical components of the machine, including the refrigeration valve, compressor, outlet valve, inlet valve, and also the lights tell you various parts about the machine that are operating and whether or not we're in coin vend or whether we're in free vend. So these are just some of the examples of how the diagnostic testing system works. We'll cover this BreakMate feature in much more depth later on in this tape. Everything we have covered thus far has been a review of Level 1 service training and is what you need to know to set up and install the BreakMate and train the key operator. There's one more basic we're set up to show you now. That's CO2 filling. To fill the 1 1/4 pound CO2 cylinders, you need a filling kit, a 50-pound CO2 cylinder with a dip tube, and a freezer for chilling the empty CO2 bottles in order to speed up the filling process. After attaching the CO2 line from the filling head to the 50-pound cylinder, close the inlet and vent valves at the filling head. Open the valve on the 50-pound cylinder. Then place a 1 1/4 pound empty cylinder from the freezer into the filling head and close the latch. Open the fill valve at the fill head and allow the gas to flow into the cylinder for about 45 seconds or until the gas stops flowing. Shut off the fill valve and open the vent valve. Lift the latch and remove and weigh the cylinder. A filled BreakMate cylinder should weigh between 3 pounds 3 ounces and 3 pounds 5 ounces. Do not exceed 3 pounds 5 ounces total weight. That's about all there is to it. We will cover some additional safety precautions later on CO2 filling. In our next video training segment, Dick Miller will cover the principles of operation of the BreakMate.
In this section of the program, I'm going to discuss with you the operating principles of the BreakMate GA3000 dispenser. You'll find all the things that I'm going to talk about outlined in Chapter 4 of the service manual. But we'll start with the very basics, the description of the product. The product is a cup of high-quality carbonated beverage. And in order to supply a high-quality drink, we need 3 high-quality ingredients applied to the dispenser. first ingredient is water plumbed into the dispenser. The water is filtered for taste and odor removal to make sure we've got the highest quality water. We need syrup, the highest quality syrup product in a disposable tamper-proof package, which is freshness dated to assure that the quality is always the best. We need CO2 gas. The CO2 gas is in a special cylinder made for the GA3000 dispenser. It's operator refillable, and it's food-grade carbon dioxide gas. Now we'll see how the dispenser makes the drink and give it the characteristics that we want. The finished drink has 4 characteristics that we're going to talk about. The first one is carbonation, which provides the fizz and the tang and the flavor of the drink. The carbonation is a mixture of CO2 with the water that's in the system. We're going to talk about the syrup ratio. The syrup ratio is the proportion of syrup and carbonated water which is mixed to meet Coca-Cola specifications. The third characteristic is the temperature. We want the drink as cold as practicable. The fourth characteristic is mixing. We want a uniform mixture when the syrup and water are put into the cup. The dispenser processes these ingredients, and the drink comes out to meet certain specifications. For example, we have a carbonation of 3.5 volumes optimum level. The carbonation is measured in volumes, and a volume of carbonation for a cup is 1 cup of gas dissolved in a cup of water. Now we're talking about 3.5 volumes of carbonation, so we'd have 3.5 cups of CO2 gas dissolved in water to have 3.5 volumes of carbonation. The next specification is temperature. The temperature of the drink coming out of the GA3000 dispenser is between 34 and 36 degrees. This is the coldest practical temperature that you can serve a drink. The next specification is the syrup ratio, the ratio of syrup to water. And the standard specification for the syrup ratio is 5 parts of syrup, or 5 parts of water to 1 part of syrup. In a 6-ounce drink, for example, there is 1 ounce of syrup and 5 ounces of water to make a 6-ounce drink. The specification for mixing is to have the same mixture between top and bottom held to within 5%. So we want the dispenser to hold that mixing. The next specification for the drink is the drink size. The GA3000 dispenser will serve 2 different drink sizes, 1 6.5 ounce and 1 10-ounce drink at the customer's choice. Let's talk about the dispensing system and how it works to mix the ingredients, the 3 ingredients that we've talked about, to get the 4 characteristics of the drink that we've discussed in order to meet the 5 different specifications that we've just outlined. And here's how the system works. Water is pumped to the carbonator where it is carbonated by carbon dioxide gas from the CO2 cylinder. The refrigeration system cools the carbonated water and the syrup compartment. When a customer presses a selection button, chilled carbonated water is dispensed into the mixing channel with a measured amount of syrup. The syrup and carbonated water mix and dispense into the cup. And that's all there's to it. Let's take a look at the real machine and see where the parts are located to handle the various ingredients in the system. We've talked earlier about the 3 ingredients that go into a dispenser: the water, the CO2 gas, and the syrup. Let's talk about the water system and see what the path of flow is. The water line connected to the back of the machine is connected to the water inlet valve. Water flows from the inlet valve to the water pump, out of the water pump through a double check valve. Let's take a look at these parts of the water system. This is the water inlet valve. This is the connection in the back of the machine. The water inlet valve is an electric solenoid valve with a coil, 115 volt AC coil. The inlet valve has a flow washer in it which keeps the flow of the water into this dispenser at 1/3 gallon per minute, and it feeds the water into the water pump. This is the water pump. It's a turbine type pump operating at 10,000 RPM, and it raises the pressure of the water to 75 pounds per square inch at the 1/3 per gallon minute flow rate. Water coming out of the pump goes through a double check valve. The double check valve prevents backflow of the water or backflow of CO2 gas into the system because the carbonator has 75 pounds pressure, and if there were no double check valve in it, it would push water and CO2 gas right through the pump back into the water line. So the double check valve is a backflow preventer, keeping CO2 gas from backing into the water line. Once water's gone through the double check valve, it flows through the water line up into the top of the carbonator. Now we'll take a look at the carbonator, which is this assembly, which is insulated. It keeps the carbonator from warming up. This is what's inside the insulated area. Carbonator is a half-gallon stainless steel tank. It's wrapped with refrigeration coils to provide the cooling for the water. The refrigeration cools the water on the inside of the walls of the tank and generates an ice bank, which gives us the cooling and some holdover capacity. The carbonator has several functions. It cools the water, it stores the carbonated water, and it does the carbonation. The carbonation is accomplished by means of an agitator, which is fastened inside the carbonator. The agitator is an electric motor driving an impeller. The path of the water is up through the bottom of the agitator, and it's expelled through these openings around the sides of the agitator. The water coming out of the agitator is directed against the ice on the side walls of the carbonator to give us the cooling. At the same time, we have an opening in the top of the standpipe on the agitator. CO2 gas enters the standpipe and mixes with the water and causes CO2 bubbles to come out through these openings. At the same time, the water comes out for cooling. The CO2 bubbles coming out of the water give us the wide area of CO2 gas in contact with the water, and that's what gives us the carbonation. Carbonation occurs when you have CO2 gas in contact with water, and the temperature of the water is down as close to 32 degrees as you can get it. So now we have, our water has come into the system, we've raised the pressure, we've put it into the carbonator, and we have carbonated water which is now cooled and stored in the carbonator. One point I'd like to mention about the carbonation and about the cooling. At the time the unit is plugged in and the water in the carbonator starts to cool down, the temperature in the carbonator drops. And it continues to drop. It goes down from, say, 60 degrees from the incoming water. The temperature drops 50, 40, 30, gets down to 32 degrees and continues to cool. The water in the carbonator actually will get down to 25 degrees in that range for probably 2 or 3 minutes. This cooling cycle takes about 30 minutes from the start of the cooling to drop down into the 25-degree range. You'll recall earlier that we suggested dispensers be set up in the shop and you build an ice bank. And the reason we want to do that is if a drink is drawn during the time that the water is down in the 25-degree range, it will immediately turn into ice crystals as it's delivered to the system. So it's one of the characteristics of this type of carbonator that the water will cool down to 25 degrees before the ice bank starts forming. Once the ice bank starts forming, the water immediately goes up to 32 degrees. And that's the temperature that is normally stored in the carbonator. So during this pull down period, during the time the water is at 25 degrees, if water is drawn during that time, you will get ice crystals coming out and they will fill the mixing channel. So we want to be sure that when the dispenser is installed on location, we have the ice bank already formed. Now we have carbonated water stored in the carbonator and cooled, and now we need to dispense it. Water comes out of the bottom of the carbonator and is fed into the outlet valve. This is what the outlet valve looks like. It's in the machine. It controls the flow of the water, turns it on and off with a solenoid valve. It controls the flow of the water, and it gives us an adjustment. In the lower end of the outlet valve, we have the flow control. And the flow control maintains a constant flow rate regardless of the carbonator pressure. If, for example, during the pumping cycle, the pressure in the carbonator should rise above 75 pounds, the flow of water will be constant because it's equipped with the flow regulator. Let's take a look at the flow regulator and see how it works. It's screwed to the bottom of the outlet valve with 3 screws. The flow control separates from the valve. And we can see the individual parts of the flow control and see how it operates. We have a piston, stainless steel piston, and a stainless steel cylinder. And we have an operating spring to give us pressure against the cylinder. As the water flows in through the valve, it presses on the piston and pushes against the spring pressure. And the bottom of the piston will modulate the flow through these little tiny holes at the lower end of the cylinder. The spring pressure against the piston is adjustable through the adjusting screw, and you can adjust the flow rate simply by turning the adjusting screw. This is the adjusting screw operating against the push rod and the spring in the piston. The adjusting screw for the water is the only adjustment on the dispenser. The screw is located at the lower end of the valve, and it's accessible to the serviceman so that it can be adjusted even while the machine is assembled. The adjusting screw gives us 2/3 of an ounce change in flow rate for each full turn of the adjusting screw. So now we have carbonated water. We fed water into the system, raised the pressure, applied CO2 gas. We have carbonated water, and we have our outlet valve to turn the water off and on and has the flow rate. So we've accounted for 2 of the ingredients coming into the system. Let's talk about the the CO2 and how it gets into the carbonator. CO2 is stored in this special cylinder made for the GA3000. It holds 1.25 pounds of CO2 gas at 800 pounds pressure. And it's inserted into the CO2 well in the dispenser. The pressure regulator is right above the CO2 cylinder. And it reduces the 800-pound pressure in the CO2 cylinder to the 75 pounds which is used to carbonate the water. The CO2 cylinder is equipped with a safety burst disc which relieves the pressure in case of overfilling or in case it's subjected to high temperatures. We can tell whether a cylinder is full or empty by pressing on this little pin. If you have any occasion to wonder whether you've got CO2 in a cylinder or not, you can tell whether it's empty. If the pin presses in easily, then you know that the cylinder is empty. The CO2 regulator has several features. In addition to reducing the 800-pound pressure from the regulator to 75 pounds, it's equipped with the little red button which is used to reduce the pressure in the carbonator. It's also equipped with a pressure relief valve which is set for 75 pounds. And in the event that the carbonator pressure would rise above 75 pounds, this valve opens up and simply bleeds the pressure back to 75 pounds. This can happen during filling of the carbonator. If the red pin is out and the vent is closed here, then the gas in the carbonator will compress as the water comes into the carbonator and raise that pressure to the 90-pound level where the relief valve starts to bleed it off. In addition to the bleed valve and the pressure relief valve, the pressure regulator is also equipped with a check valve. The check valve prevents water from coming out of the carbonator back into the pressure regulator. That's right behind the fitting on the bottom of the pressure regulator. So now we have 2 of the 3 ingredients directed into the dispenser, and we've learned how they're controlled. Let's talk about the 3rd ingredient, which is syrup. Syrup is delivered in tamper-proof sealed cartridges. It has a seal on the top to keep it sterile during handling. It's a single-use container. This is an empty syrup cartridge which has the proportioning device left in the neck of the cartridge. When the doser is inserted in the cartridge, doser is dropped in gently, and then it's turned tightly until you hear it click. When that happens, you know the doser is properly seated. When the doser is removed, then the proportioning device falls into the cartridge, which ensures that it cannot be used again. So we have the syrup delivered to the doser. And the doser is the device which measures the syrup and delivers it into the mixing channel. The doser is a positive displacement valve. It has a seat on the bottom and a seat on the top. The lower seat seats against the bottom of the shell of the doser so that when it's in its normal down position, syrup can't come out. During the dispensing cycle, the doser plunger is lifted And the upper seat closes off to prevent any more syrup from coming into the cartridge while the portion is delivered. The doser operates twice for a 6.5 ounce drink. And each operation of the doser gives 1/2 portion. For a 10 ounce drink, the doser operates 3 times. The portion of syrup for a 6.5 ounce drink is about 1 1/10 ounces, and for a 10 ounce drink, it's about 1.65 ounces. We ask you to instruct the key operator to wash the doser with warm water when changing it to a new cartridge so that the syrup doesn't collect or get sticky and cause a malfunction of the doser. The syrup portions delivered by the doser are at the prescribed portions of 1 1/10 ounces for a 6.5 ounce drink when the syrup is at 45 degrees. If you should have occasion to measure the syrup when it's warm, you'll find the portions may be slightly higher because the viscosity is lower. So when checking syrup portions, be sure you're checking it with cold syrup. Now, what makes the doser work? We have in the plunger of the doser a stainless steel magnetic ring. And that ring is operated by the doser coils, the 3 doser coils in the dispenser, 1 for each flavor. This is what the individual doser coil looks like. It's simply a magnetic coil with an iron frame on it. And when it's energized with a 100 volt DC. That provides a magnetic field. When the current to the doser is turned on, it lifts the plunger up and gives us one dose of syrup. It operates twice for a 6.5 ounce drink, 3 times for a 10 ounce drink. The dosers are readily removable. They're held in with snap clips. The electrical connections are push-on tabs at the coil. Well, now we have our ingredients, all 3 ingredients. We've put the water into the machine, we've put CO2 gas in, we've put syrup in, we've carbonated the water, and we've cooled the water. We've provided a method for measuring both the water and the syrup by the operation of the syrup valve and of the doser. Now, those ingredients, carbonated water and syrup, are delivered to the mixing channel. Let's see what happens next. The mixing channel in the dispenser has the inlet for carbonated water at the right-hand side as you face the machine, and the syrup dosers drop the syrup through the 3 openings in the top cover. Top cover of the mixing channel fits in a recess. And when you're installing the mixing channel, you should be sure that the cover is in place, otherwise the mixing channel won't fit properly. The water is delivered and covers the mixing channel during the length of the dispensing cycle. And the syrup is dropped into the mixing channel on top of the water in 2 or 3 portions. The water continues to flow for a slight period of time after the syrup is flowed through to clean out the mixing channel so there's no carryover of flavors. Then the drink flows through this outlet screen. The purpose of the outlet screen is to give complete mixing to the drink as it pours into the cup, so that we get the same mixture at both top and bottom of the cup and don't have a watery taste at the top of the drink. This mixing screen is removable for cleaning, simply pressed into place, and the key operators are instructed to remove this for cleaning in the event that you get any dirt in it. They should also be instructed to press it back in place, because if the screen is not in the mixing channel, the drink will not drop straight down from this outlet spout. It'll tend to go over to one side and may miss the cup, and you will not get good mixing. So be sure the screen is put back in place after removing it for cleaning. So now we have all of the ingredients in the dispenser, and we want to talk next about the refrigeration system and see how the cooling is done. Let's point out the major parts of the system. In general, the refrigeration system is the same basic system as you have in your home refrigerator or even in your auto air conditioning. The refrigerant is a Freon 12, R12, the same as is used in auto air conditioners. The elements of the refrigeration system are the compressor and the static condenser, which are the tubing and fins on the back of the dispenser. The evaporator, which is the copper coil wrapped around the carbonator, and this wall in the syrup compartment. We have two cooling areas which are called evaporators, one for syrup and one for water. The cooling to the carbonator has first priority for the refrigeration system. It builds the bank, the ice bank on the carbonator wall to give us the cold water. Water is the major ingredient, and the water must be cold in order to get a cold drink. After the ice bank has been formed and the refrigeration to the carbonator is satisfied, a sensor in the carbonator, which is an electrode, senses that the ice bank is complete and signals the ECM board to operate the refrigeration transfer valve, which is located in the left rear wall of the dispenser. The refrigeration transfer valve looks like this. It's a three-way solenoid valve with an inlet port which comes from the condenser, and it will direct the freon gas, the refrigerant gas, either to the carbonator or to the syrup cooling compartment. And it's controlled by the ECM board upon getting a signal from either the carbonator or from the syrup cooling compartment. The compressor, as with almost all compressors, has a starting relay. That's located on the side of the compressor. It's removable for servicing, and the connections to the compressor are located on the side. The syrup compartment evaporator is this white lining inside the syrup compartment. Now, under normal operations, moisture condenses on the walls of the syrup compartment evaporator. Near the end of the refrigeration cycle, that moisture may freeze and give a little ice buildup. That's nothing to be alarmed about. It's normal in the refrigeration cycle. And once the refrigeration cycle is complete, that ice melts and the water drains out through a little drain down into the drip tray on the dispenser. That completes our discussion of the cooling system. Let's talk about the electrical system next and the electrical parts. Power is supplied to the dispenser through the line cord coming into the back of the dispenser. And it comes in and is connected to an inlet filter which prevents any interference or electrical interference from going back into the power line. From there, the power line is fed into the main switch on the dispenser. That's a two-pole switch which cuts both sides of the line. The power then goes through the main switch when it's turned on and goes to the agitator. The agitator runs continually while the switch is on so that the cooling and carbonation functions continue regardless of what else happens to the machine, as long as the switch is turned on. Now all other electrical parts of the system, other than the agitator, are connected to the ECM board, and they're controlled through the board, which is located on the front panel of the dispenser and looks like this. As far as the electrical connections are concerned, you should note that the water inlet valve and the water pump are connected together electrically and operate at the same time on the 115-volt circuit. The compressor is also on a standard 115-volt circuit. The refrigeration transfer valve is on a 140-volt DC circuit. That's to prevent any humming or pulsation in the valve from an AC line. Same thing is true of the doser coils. They're on a 100-volt DC circuit, so you don't get any vibration or humming in the doser valves. We also have a transformer located just above the water pump, and that provides a 10-volt AC circuit to the circuit board for its control functions. We have a pressure switch, which is in the CO2 line, which will indicate when the pressure in the carbonator has dropped if the CO2 cylinder is going empty. When the pressure drops far enough, this switch operates and turns on the blinking yellow light on the front panel that we talked about earlier. So basically, all of these electrical components are connected to the ECM board except the agitator, and there are no control functions other than in the ECM board. So electrically, the dispenser is relatively simple. All of the parts are connected with plug-in leads and can be replaced easily. Now let's talk about the functions of the ECM board. The ECM board is the control center of the dispenser. All of the functions of the dispenser are generated by the ECM board. I'll go through the major functions. First of all, it provides the selection buttons on the top 3 buttons of the selector board. The ECM board controls the function of the water pump. The water pump signals. The water pump is signaled to operate from an electrode in the cover of the carbonator. When the water level drops below this electrode, it sends a signal to the ECM board and indicates that the pump should run. So the ECM board then turns the pump on. Now the ECM board has several built-in safety features in it. For example, it limits the initial pump running time to 2.5 minutes. In the event the water is not fed into the carbonator and does not reach the electrode in a 2.5 minute time, the timer simply shuts the pump off and protects it. Once the carbonator has been filled, there's a second timer which takes over pump control, and it limits the pump running time to 45 seconds under normal conditions. The ECM board controls the refrigeration, and it controls it from 2 sets of sensors. One set of sensors is the electrode in the carbonator, which senses whether or not there is an ice bank touching the electrode. Just the tip of the electrode is exposed to water in the carbonator, and when the water freezes in that area, when the ice bank is formed, the ice is an electrical insulator and stops the tiny sensing current from going through the electrode. So the ECM board picks up the signal and shuts off the refrigeration. Or in the case of the carbonator, when the electrode's covered, it transfers the refrigeration to the syrup compartment through the syrup transfer valve. The second sensor for refrigeration is located in the syrup compartment. It's in this little boss on the front of the evaporator. And the sensor in the refrigeration compartment is a resistor which changes resistance with a change in temperature. And at the point where the temperature is low enough, it sends a signal to the ECM board to turn the compressor off. So the refrigeration system has then satisfied both the carbonator and the syrup cooling compartment. The next function of the ECM board is to provide for two different drink sizes. You saw earlier under the coin mechanism demonstration that there is a drink size switch, and that simply sends a signal to the ECM board to determine whether the dispenser should dispense a 6.5 ounce drink or a 10 ounce drink. The ECM board provides signals. The upper green light will indicate a 6.5 ounce drink when it's lit normally. If it's blinking, that means that the pump is run too long and one of the two timers has operated to shut the pump down. So the top light blinking is an indication of the timer having run too long for the water pump. The lower green light blinks. That means that water has dripped into the dispenser and operated the water sensor. Let's take a look at the water sensor. It's located right at this point and consists of a terminal which is spaced from the base of the dispenser about 1/16 of an inch. If a drop of water gets between the terminal and the base of the dispenser, it completes the circuit and sends a signal to the ECM board that there is moisture in the system, and it shuts down the water pump and the water inlet valve so that they cannot operate any longer and put any more water into the machine in the event of a leak. The ECM board has two fuses. It has a 100 milliampere fuse and a 2.5 amps. Now these are not line fuses. These do not protect, their intention is not to protect the dispenser in case of a short circuit. This protects the two power supplies in the ECM board which provide the DC voltage to the transfer valve or to the doser coils. However, if either one of these fuses blows, then you will not have a green light indicator on the ECM board. So that must be replaced if it blows in order to get the board back in operation. One further note, this fuse in the position that it's in on the board can be pushed out of position when installing the board in the dispenser. So in the event you do have a board which doesn't have any indicator lights on, it's a good idea to check this fuse and make sure it's in position. In addition to these functions, there are various other control functions which are primarily for the electronic operation of the ECM board. But the diagnostic procedure, which was discussed earlier and will be shown in greater detail under repair procedures and troubleshooting, enables all the electrical components to be tested, in addition to showing the condition of all of the sensors in the dispenser. This section completes the description of the operation of the parts of the BreakMate dispenser. You can find further details in Chapter 4 of the service manual, and you'll want to refer to the manual for further information on the operation of the equipment. We're now going to turn the program over to George Swift, who is going to go into troubleshooting and repair procedures.
I'd like to begin the troubleshooting section by considering a few basic things about the troubleshooting process. First, the goal of troubleshooting, at least for our purposes, is to locate and repair a malfunctioning component in a system and do it as efficiently as we possibly can. In our case, with the BreakMate, we have a post-mix soft drink dispenser that's composed of 5 systems, and these 5 systems interact to produce excellent, cold, correct carbonated beverages. The systems involved are water, syrup, CO2, refrigeration, and electrical/electronic. You need to use all the information you can muster in troubleshooting to help with your diagnosis. Many of you already have had experience and training with troubleshooting other pieces of equipment, and you can use things like volt-ohm meters or little continuity testers. But also, don't forget, your human sensory equipment is valuable. You can observe many problems just by careful looking. A proper running refrigerator system will feel warm at the condenser and cold on the evaporator. You can also feel the tug of an electromagnet. A warm, non-carbonated drink is something you can taste, and the hiss of a CO2 leak or the change in sound of the pump motor are audible bits of information you can use. Now, in addition, this machine has many features designed to help in troubleshooting by giving you more information on which to base your diagnosis. The most obvious features are the green light indicators. Steady state green lights gives you status of various components, but a blinking light signals some kind of a problem. Now, if we have a blinking A light, such as we have here, and we've listed our lights A, B, and there's another light C, which is covered up now. The blinking A light means the pump has shut off on its timing cycle. Now, just a reminder, the pump has 2 timing cycles. One is 2+ minutes, and the other is 45 seconds. The 2+ minutes is only a one-time feature. Now, this timing feature is built in to protect the pump as well as to alert the operator of a problem. Now, the pump is not designed to run without water because it could damage the impeller in the pump. So when you see a blinking green light, the A light, first of all, you want to turn the machine off. Now, this resets the timing cycles. The next thing you want to do is turn your attention to the water supply. If it's been shut off for some reason, then look for the reason. Look for valves not fully turned on, for pinch lines, look for a filter being clogged, or even see if there's low pressure in the building. And the easy way to check is to just disconnect the machine at the back and check for 4 quarts a minute flow rate. Then you know you've got enough water to run the machine. Then you reconnect the machine with this good water supply, and then you bleed the pressure off by pressing the red relief valve pin until it stays in by spring pressure. This will accomplish letting any air that's trapped into the system come on through the line and into the carbonator and be bled out. Then you want to turn on the machine. As you turn on the machine, learn to listen. Listen to the pump sound as it's pumping. A low whine, such as you hear now, with fewer RPM means the pump is under a load and pumping. Then let it run. The pump has 2+ minutes at this time. Remember, we've reset the timing cycle to fill the carbonator. If it doesn't fill the carbonator, the pump is probably faulty and should be replaced. Now, we'll cover how to replace the pump, and we'll cover how to replace all the segments we discover bad. We'll cover that in the next section. If it does fill the carbonator and shut off and you have a steady green light, then I suggest you draw a drink or two just to make sure it shuts off on the 45-second cycle. If it does, then all's well. Now, if there's a high-pitched whine when you turn the pump on, then the pump is not pumping. At this point, again, turn the machine off, and check the inlet valve. If the inlet valve is operating properly, and over 99% of the time they will be, then the pump is faulty and needs replacing. Now, the inlet valve is operated by an electromagnet and is connected electrically to the pump so that when the pump runs, the inlet valve is on. Now let's turn our attention to the B light. If you see the B light blinking, it tells you that water has reached the sensor in the bottom of the machine and the pump and inlet valve have been shut off to prevent any further water leaking inside the machine. Remember that a leak occurring outside or behind the inlet valve is not stopped by this feature. Now there are two causes that are most likely to cause the lower light, the B light, the green flashing light to come on. One, and the most probable, is leaky water connection or a leaky fitting or a leak in the tubing inside the machine. The other, less likely, is that the pump doesn't shut off and it overfills the carbonator, which causes water to back up through the CO2 regulator and comes out the safety relief valve on the regulator, flowing down into the CO2 well and then onto the safety shutoff sensor. The first thing to do would be to put the machine in the test mode, and once it's in the test mode, then go and press button 4 to determine if the lower green light indicates low carbonator, and it would indicate that by being on. If it doesn't, then press buttons 2 and 4, which activates the outlet valve, and drain a little water out until the lower light does come on. Then turn the machine off. At this point, remove the front panel so you can get to the sensor and dry it off. Now, we normally use compressed air or compressed CO2 to blow the sensor dry, and it's very sensitive and it's hard to dry off. If you turn the machine back on and the B light is still blinking, then look at the edge connector where the sensors connect to the ECM board and dry them off. Occasionally water will get on that and it'll act just like the sensor. Then stand the panel up and carefully turn on the machine and lean it forward so you can look inside to determine if you have an internal leak. If you have a leak inside in a fitting or a hose, then repair it and dry the machine off. Now, if it's the pump overfilling the carbonator and the pump won't shut off, then first check the probe lead to the water level connection in the carbonator. The other possibility is that you have a stuck relay on the ECM board which makes the pump run all the time. In that case, change the ECM board and then you should be working. What if you see the machine is giving little or no water but a full amount of syrup? If you recall how the systems work, then it has to be there's no CO2 pressure to push the water out, or there's a problem with the outlet valve flow control mechanism not letting the water through. If you have good CO2 pressure, and this is easy to determine, you look at the CO2 light to see if it's blinking, or you can press the red pin and listen. If it's not CO2, then it's probably the outlet valve flow control. First thing to do is to take off the front of the machine to get to the valve. And at this point, you need to check and clean the flow control. We'll show you later how to take out the flow control and how to take it apart, because most of the time it is the flow control that needs cleaning. To see if the outlet valve is energizing, it's easy to do at this time. You just turn the machine on, put it in the test mode, and energize the outlet valve to see if it will expel water. There's one other possibility. You could have slush ice, which will jam up the outlet valve, but we'll discuss this later. And if the water is only a little bit short in volume, you can adjust the flow control to increase and decrease the flow of water. Now remember, syrup is a fixed throw or a fixed amount. Now, if the outlet valve does not shut off, then turn off the machine. If the water shuts off, then probably there's a relay stuck on the ECM. If not, it's a faulty outlet valve and you need to replace it. Now I want to talk about a stuck check ball in the CO2 regulator. This problem is seen most frequently during the machine setup in the shop. After bleeding off the pressure to fill the carbonator, the red pin stays in. Then upon installing a full CO2 bottle, the machine will not accept CO2. You know this because you cannot hear the CO2 entering the carbonator and the red pin doesn't pop out under CO2 pressure. No further checking is required to know the CO2 check ball is stuck. The problem is more frequent when the CO2 bottle is colder and the bottle pressure is low. CO2 pressure in the bottle is a function of the temperature of the bottle. In the summertime, a warm CO2 bottle will usually have higher pressure and will unseat the ball quicker. What you do is engage the bottle and let it sit, then loosen and engage it again. And you do this a few times, and very often this will unseat the ball. But as a last resort, you have to take the front and the back off the machine to remove the regulator and loosen the ball. Now this is a regulator out of the machine, and there's a ball located under this fitting that's the culprit. And as soon as you take the fitting off, you can get to the ball, and this is what it looks like, a small rubber check ball. Once it's loose, it will usually stay free. To put it back in, be sure the regulator is in an upside down condition like this so the ball falls all the way down, and then you reinsert the fitting and reinstall the regulator. After you've done this, you shouldn't have any further problem. Now in newer models, they've redesigned this part so you won't have any problems, but you may see this from time to time and you need to be prepared. The Electronic Control Module, or ECM, is really the mind of the machine. It takes the sensor's input and it takes other commands like buttons being pushed, and it keeps all the systems doing what they're supposed to do. But occasionally something can go wrong with the board itself. For instance, on the board there are two fuses. One is a 2.5 amp fuse. The other is a 100 milliamp fuse, and they will occasionally blow. If you replace them and they continue blowing, then you'll just have to replace the board. Another problem is occasionally internal relays on the board will stick, and again you have to replace the board. It's an easy job to replace the board, and we'll show you how later. Sometimes a component in the system will fail and short circuit, and it'll burn a trace on the board, and you'll see it'll be a dark brown burn place. So before you replace the board, you can check which edge connector the burn trace leads to, and then repair the component that has failed. Now page 7.1 through 7.3 of our manual includes wiring diagrams and edge connector schematics, and it has a listing of proper ohm readings for the components so you can locate the one that failed and replace it before you put the board back in and try to turn the board on and have it burn another trace. Now let's give our attention to the refrigeration system. The BreakMate has a fairly standard refrigeration system, with maybe the exception of the split evaporator system and diverter valve, which directs the freon to the carbonator or syrup cooling compartment as called for by the sensors. Upon immediate startup, the condenser should begin to get warm. The syrup compartment should not get cold for an hour and a half to 2 hours, because priority is given to the carbonator for building the ice bank. This you can feel. After the syrup compartment begins to get cold, you should be able to look in the diagnostic mode and see the normal ice bank light off and the super ice bank light on. And these are good checks you can make before installation to be sure you have proper ice bank. Now in a low refrigerant situation, you might find that there's a lack of an ice bank built up, and therefore the probe is not satisfied. This would cause the syrup compartment to be denied Freon and would stay warm because the diverter valve will not switch until the ice bank is built up. Another situation might be overuse of the machine, where it's used beyond its capacity might cause the machine to not have an ice bank or not be able to keep up. Or you could put it in a hot location because the machine is designed basically for a 75-degree environment to work properly. These can cause warm and low carbonated drinks. But generally the refrigeration system does a super job and produces an unbeatable post-mix beverage. Now on page 5-6 of your new manual, we have included a refrigeration decision tree. Since the sealed refrigeration system is a part of the machine that requires returning the whole machine to our authorized repair depot for warranty repairs, we want to be sure, and we want you to be sure, it's really a refrigeration problem so you don't suffer any unnecessary shipping expense or other costs. Now turn to section 5-6 and let's take a sample run through the maze. It's really simple. You follow the arrows, you answer the questions, and then you proceed to the block that tells you what the problem is with the machine. As we talked earlier, sometimes slush ice is the culprit that causes us not to get the proper water for a correct drink. And slush ice is a condition. It's actually a stage in the ice building process. It occurs when water has been supercooled to maybe 25 or 26 degrees Fahrenheit. If a drink is drawn during this period, ice particles will block the outlet valve open and slush will be delivered into the mixing channel. Now after the flash period, the hard ice forms, and this condition will not repeat in the carbonator unless the machine is overused and the ice bank is melted and you begin a new pull down like during the startup period. Now this has been a brief overview of the troubleshooting of the BreakMate. We've not tried to cover every detail, but we hope we've gotten you off to a good start. And we're sure that we're going to be available to help you if you run into troubleshooting difficulties, so you can call us. Here in section 6, we're going to deal with repair procedures. And here we're going to get into the machine, take off the front and the back, and take out the components and get into how to remove and replace them. One of the first things you might want to do is, if you have to get into any part of the water system, is to be sure before you've gotten into the machine that you drain the carbonator. And this is a fairly easy process, but it's something important you need to learn. The first thing you'll want to do is get the cover off of the ECM board. You do that by taking out the screw, prying up gently on the corner, and lifting the cover off. Then you want to take out your mixing channel, and then you want to put the machine in the diagnostic mode. And remember how you do that? You press button 4 as you turn on the machine, and you get the blinking lights. If sometime putting it in the diagnostic mode, if you turn it on and the buttons are all steady, it only means your super ice is on, and you just punch the button again and then it starts cycling. At this point, check your buttons. Go down through each button And now you're in the test portion. To drain the carbonator, you need to get a pitcher, hold it under the outlet valve, press button 4 and 2 at the same time. This will drain the carbonator because the pump will not activate as you're draining the water out, and you can completely drain it dry. Now, if you want to pump, then you just press button 4 and button 1, and as you can hear, the pump starts. Now, how do you know when the carbonator is full of water so that you don't overfill? Well, watch the B light. As we drain the carbonator, you notice the B light comes on. That tells us that the water level is down. But as we run the pump until the B light goes off. And then we know we've filled the carbonator. So now we drain the carbonator. And once it's drained, then we remove the CO2 cylinder and take the pressure off. And now we're ready to get into the machine. Okay, now we have the CO2 empty of water and gas, and we're ready to go on with taking the machine apart. First, let me show you how to take off the ECM board. It's very easy, but one of the big things you want to do is turn the machine off and unplug it. Then you have 2 screws. You don't have to take them out all the way, just loosen them. After you've loosened these 2 screws, your ECM board tilts back and lifts out like this. Now, to take it all the way out, all you have to do is disconnect the edge connectors. Just very gently rock them off, and your board is out. Now, to take the front off of the machine, you've got 12 screws that you need to take out. First thing you want to do before you can get to the screws is remove all the front pieces. We already have the mixing channel out. Now we remove the drip tray, and then we take off the syrup compartment cover by just pulling the little pin out and then removing it. Now all 12 screws are exposed. Think of them in terms of threes. There are 3 here, there's 3 here, there's 1, 2, 3 here, there's 2 inside the CO2 compartment, and there's 1 right here. So now we take off the screws. The order of taking them out is not important, but the order of putting them back is somewhat important. You should put these 2 screws in first and then this screw in next to be sure you don't drop a screw down in the CO2 well and have it fall down inside the machine. I use a magnetic screwdriver because it holds onto the screws and lifts them across. Now we're ready to take off the front, and all you do is just slide it forward and lay it down, and you can see you've got enough harness to lay it down in front, and most of the things you want to get to are available right through the front of the machine. With the front panel down, the thing you can see most readily is the doser coils. If you ever have to remove one, it's very easy. You just pull the tabs aside, lift the doser coil out, and disconnect it from the wires. Now, just a word of caution, it's good not to disconnect the wiring harness unless you absolutely have to and take the front completely off, because they're on so tight that you can risk damaging some of the little connections just by taking them on and taking them off. Now let's go ahead and talk about the flow control. We mentioned it in the troubleshooting section. And the flow control, the outlet valve flow control is actually two parts, as you saw what Dick told you. So if you're having a problem with the flow control, you can take just that part off by removing the 3 screws. I've already removed 2 of them, and I'll just remove the 3rd one here, and you can see that it comes right apart. And you have the flow control portion then separated from the actual outlet valve. Now, if the flow control is sticking, it just comes apart, the piston out of the barrel, and what you want to do is clean it until you get real good smooth action so that it will slide back and forth when you shake it. When it's at that point, then you know it'll work. Also remember that the holes go opposite when you reassemble. The hole in the piston and the hole in the barrel are on opposite ends. Now, if you have to go on and take off the actual outlet valve, it's very simple. You just loosen the plastic nut and pull off the wiring connections. I told you they were hard. And once they're off, it doesn't matter how they go back on, then you have the whole flow control and the outlet valve mechanism out. In the troubleshooting section, we mentioned that you might have to remove the CO2 regulator to free the stuck check ball. To do that, you have to remove the rear cabinet. There are 2 things you can reach that you have to remove the rear cabinet to get to. One is the regulator, the other is the top of the carbonator. There are 12 screws on the back also. You have 2 screws located underneath this side, 2 screws on the underneath of the opposite side, 4 on the top, and you have 4 on the bottom. Now, I've taken the liberty to take most of those out except for one, and I'll take the last one out, and then we'll slide the cabinet off and set it aside. Set it down here. Now we've exposed the rear of the machine and the top of the machine. To get the regulator out, there are 2 bolts holding it in the back. You have to release the condenser coils from their holders by just snapping them back so you can get to the screws. Then, this is one of the few places you'll need a wrench to loosen the bolts. Once they're loosened, then you just take them out. Okay. Lay them aside. Lay the other one aside. And then you have to come back to the front of the machine to finish the job. Now you need to remove the CO2 bottle well, which you can do, and then you pull down the CO2 regulator. You can get a little room by pulling on it because the hoses will give you some slack. Then all you do is loosen the fitting with a wrench and hold it as you turn the regulator. And this takes the regulator off. And be careful and don't lose the check ball when you take it off. And when you replace it, remember again, be sure it's upside down like this so the ball drops to the bottom and doesn't go to either side. As we mentioned, the other component that you can reach after you take off the back cabinet cover is the top of the carbonator assembly and the agitator assembly, which is located inside the carbonator. So let's take out the agitator assembly. The first thing we have to do is remove the 4 screws that hold on the insulated cap cover. And then we take loose the ground wire and the pump electrode wire, and then we loosen the nut that holds the cover clamp on. And I've taken the display model to show you what happens after we remove the clamp and the cover of the carbonator. You remove the clamp that holds the wire, thread the wire through the hole of the carbonator cover, and then you've exposed the agitator inside. To take it out, you simply give it about a quarter turn to loosen it, and it comes right out, and it goes back in the same way. Now we're ready to remove the pump and the inlet valve. There are 2 screws on the back of the machine that you need to take out to loosen the inlet valve. The inlet valve doesn't require taking off the rear cabinet of the machine to reach these 2 screws. Then we come around front and we disconnect all the electrical connections. Okay. And then we have 2 screws on the bracket that holds the pump in place. There's one right up under the evaporator compartment, the syrup cooling compartment. We take it out, and then there's one below it. And then we break the water line at the double check valve by just taking the nut loose and moving the line out of the way. Now the pump is ready to just lean forward, pull the inlet valve the rest of the way through, and you have it out. And a couple of things to remember: to take the little shock absorber off and keep it. Also, take off the plastic spacer and keep it, because these don't come with a new pump if you're ordering a new pump. Another thing to remember is keep your finger over the double check so that the pieces don't come out. That covers repairs, so now on to accessories.
This accessory is a remote CO2 system which permits the use of a 20-pound, a 10-pound, or other standard size CO2 cylinders in place of the 1 1/4-pound cylinder that's in the dispenser. The remote CO2 system was developed to meet requests for the use of a 20-pound cylinder in remote locations where it may not be convenient to send CO2 cylinders out on any regular basis. Also, for high volume locations, it eliminates the need for multiple cylinders at a location where you may have to have 3, 4, 5, or 6 cylinders, perhaps where there are more than one machines. So the remote CO2 kit was developed for this purpose, and we'll go through the installation procedure. At this point, we'll show you what the parts involved in the kit. This is the CO2 bracket, which replaces the CO2 cylinder and its connecting hose. We have a CO2 regulator which connects to the 20-pound cylinder. This regulator reduces the tank pressure to 120 pounds to feed into the bracket where it's further reduced in the dispenser. There is 10-foot extension of hose so that the cylinder can be conveniently located. This hose or tubing is high pressure tubing, relatively high pressure. It's 350-pound test tubing so that it will withstand easily the 120-pound pressure that we're using on it. Also, we have a coupling which is used to connect the extension hose to the tubing on the remote bracket. Also, there is a grommet furnished to be put in a hole in the rear of the machine. When a coin mechanism is used, it's necessary to drill a separate hole, and this grommet protects the tubing going through the hole in the back of the machine. So those are the parts that are in the kit. In addition to these parts, you need a 20-pound cylinder or other size standard cylinder to connect the kit to make it run. We'll go now to the installation procedure. We'll start by removing the selector panel. We'll remove the small CO2 cylinder. The next step is to loosen up the control panel. We'll shut off the dispenser while we're installing this unit. Then we're going to install the mounting bracket. The ability to install this kit depends on the fact that we have an outlet opening in the bottom of the CO2 well. And what we're going to do is to install the tubing for the bracket down through the opening in the bottom of the CO2 well that faces towards the front of the machine, and it will come out this opening just below the ECM board. Then we're going to pull it through. The hose is installed simply by pushing it through the opening. Pulling it on through. And dropping the bracket down into the CO2 well. The next step will be to thread the hose through the opening in the back of the dispenser. And to do that, we want to keep the hose below the harnesses and run it down around the base of the compressor so it's not up in the air where it might interfere with a coin mech installation. So the next step is to thread the tubing underneath the harnesses and run it out through the back of the dispenser. All right. We'll bring the hose out the back. A piece of wire, a coat hanger is helpful. Now that we have the tubing pulled through the back of the dispenser, we're going to replace the ECM board. The next step will be to couple our extension hose to the tubing that's come from the bracket. We're going to use the coupling. Simply push the tubing into the coupling. Then we tighten it finger tight on both sides. And tighten it up an extra quarter to a half turn. Don't over tighten the coupling because the plastic bushings in there will tend to break if they are over tightened. And the next step will be to install the CO2 regulator. And finally, we'll install our extension hose into the connection to the CO2 regulator. And that's all it takes to connect the system. All that's necessary now is to set the regulator for 120 pounds and to test your system for leaks. There is a complete set of instructions with each kit, so you have the testing procedure available to you when you install the unit. The accessory we're going to talk about now is the CO2 filling head and the attachment to the 50-pound cylinder. Earlier in this tape, you were shown how to fill the CO2 cylinders with the head and given a brief description of how it's done. I'd like to go into a little bit more detail with you and show you the principle of operation because it helps understand how it works and may help you to solve some problems in filling these heads. The filling of a small cylinder from a large one depends on having a pressure difference between the two cylinders. The pressure difference that we get is the difference between 900 pounds of pressure in a 50-pound dip tube cylinder and the pressure in a small cylinder which has been cooled to 0 degrees Fahrenheit in a freezer. When the cylinder is at 0 degrees Fahrenheit, gas coming in from the large cylinder will be at a pressure of about 300 pounds. And it's this pressure difference that permits this system to work for transferring gas between the large cylinder and the small one. The large cylinder holds 50 pounds of gas, and that gas is in a liquid form in the cylinder. We're transferring liquid gas. It's not gas in gaseous form. So that the flow through the hose into the filling head is liquid CO2. I'm going to go through the procedure of putting a cylinder in the filling head and operating it just as if we were going to fill it. You recall we said we would shut off the valves, open the CO2 cylinder, open the CO2 cylinder valve, put in the small cylinder into the filling head and latch it into position, and then open the inlet valve. And this will permit the cylinder to fill. With the small cylinder cold, 900 pounds in the large cylinder, the filling is accomplished in 45 to 60 seconds. You can listen to the sound that the gas makes when it comes into the cylinder to get an approximation of when the small cylinder is full, as well as using a 45-second timing on it. When you hear the noise stop, that indicates that the cylinder is about as full as it's going to get. So we'll shut off the inlet valve, vent the cylinder, and then we want to be sure to check the weight. The reason it's important to check the weight on the cylinder and not exceed 3 pounds 5 ounces total weight is because this small cylinder is now also charged with liquid CO2. And liquid CO2, like water or many other liquids, expands when it's warmed up. So if this cylinder is filled full with liquid, the minute that the temperature rises, that liquid is going to expand and there's no place for it to go. So the pressure becomes very excessive because of expansion of liquid in the cylinder. And for that reason, there's a burst disc in the top of the cylinder that's set to burst at 3,000 pounds pressure. And we've had instances where people weren't paying attention and filled it too long, and they find when they put the cylinder in their truck and it warms up, why it bursts the disc. And the only reason this disc will burst is because the cylinder has more than 3 pounds, 5 ounces total weight. So there are several safety precautions that you want to keep in mind. The first one is that when you use a gas cylinder, you must always tether it to the wall or to a firm support so it won't be knocked over. The reason you do that is because if the tank falls over and this valve hits against something and breaks off, the tank acts like a rocket. The liquid CO2 just blows this thing across the room. So remember always to tether a cylinder when you're bringing it into your shop and using it for filling purposes. The second safety precaution is when you're through filling a batch of cylinders, be sure you turn off the 50-pound cylinder and bleed the pressure out of the line. Here again, it's a safety precaution. This hose is filled with liquid, and if you shut off this valve, and if this one is also shut off, you have the liquid trapped between two dead ends, and the liquid has no place to expand. Now we do have a safety valve, a burst disc also in this hose connection, but we don't want to tempt fate and leave the CO2 trapped in that line. We'll talk a little bit about capacity of the 50-pound cylinder. With 50 pounds of CO2 gas in that cylinder, you'll be able to fill between 25 and 30 of the small cylinders. Now, you may say, we're only putting 1.25 pounds in here, and if we have a 50-pound cylinder, we should get a lot more than 25 to 28 cylinders. Well, that's true, but the physics of CO2 gas prevents you from doing that. When the liquid is withdrawn from the cylinder, when the last drop of liquid is withdrawn, the pressure in the cylinder is still 900 pounds, and that's gas pressure. But at that point, you can no longer fill any cylinders because the liquid is all gone. Now, at that point, the tank still has 20% of its initial capacity of gas in it, but it's in gaseous form, so it does you no good. The most you can get out of a 50-pound cylinder is 40 pounds of liquid gas. So if you're checking your number of cylinders that you fill from a 50-pounder, that's why the number will be between 25 and 30. Another safety precaution is handling the small cylinders in your route truck. These cylinders must not be tossed around in the truck because if the valve gets damaged or bent on the outside end, you'll find that it not only won't fit in the filling head, but you can't fit it into the CO2 regulator on the dispenser. So use caution in handling the cylinders to prevent damage to the valves, because you'll have a repair charge to replace it. Ideally, the small cylinders should be kept in a egg crate type container in your truck so that they don't rattle around. Well, those are the important points in using the CO2 filling head. Be sure and observe the safety precautions. Be sure that the latch is down completely before you open the valves, and you'll find that filling the cylinders is a very simple proposition.
This is the BA 104 remote water kit. It also is an accessory. We found in rolling out the BreakMate that there are a lot of instances where being able to plumb to water is not possible. So we found there was a great need to have a kit such as this. The way we've put it together, the main part of it is a flow-jet water pump. It comes with a 3-gallon stainless steel tank, which is refillable by the key operator. Or you can buy it without the 3-gallon tank, and it comes with an adapter that you can hook to a regular water jug. The BA104 water kit, and we use that designation for ordering it, we find works well with the BreakMate, and you can use it either in a standard location or as a demo unit. Another accessory we found out that we need, in addition to the regular installation kit which you've seen throughout this videotape with the small inline Kuno filter, we found the need for a larger Everpure filter. And what we send in the kit is a saddle valve to connect to the water line, an adapter to connect to the machine, a length of hose to hook up the filter, and we've put together a small mounting plate. The mounting plate we put together fits on the machine and makes an easy installation, although you can install the Everpure filter underneath the counter or at some remote location. But it makes it an easy installation to put it on the bracket on the back of the machine and just connect up the water fittings. Well, we've covered a lot of ground in this videotape. I hope this has been helpful service information. There are just a few more things I want to cover in the last few pages of your manual, and I hope you have your manual with you so we can page through these last items. In Section 8, you have listings of parts, and you have exploded drawings of parts with the part numbers so you can locate them easily. Now, the parts on this BreakMate machine are covered under warranty for a year. That is, everything with the exception of the refrigeration system, which is covered for 5 years. If you find that you need a replacement part, then what you do is come to this section of the manual and locate that part and the part number. And then you can call our customer service division and order the parts that you need. Their number is 1-800-627-8877. Now, that same number you can also get service help. If you need to order a part and you're going to return a part, we ask you to fill out the return goods tag so we can give you credit for your warranty return. Now, the tag is pretty straightforward. The one thing I would emphasize is that you fill out the dispenser serial number, and you'll find that dispenser serial number on the back of the machine. And the number I'm looking for starts with the letters FD, and then it would be followed by 6707 and some zeros, and then another 4 or 5 digit number. Be sure and put that part in so we can give you credit for the return part, and then attach the tag to the part firmly so it doesn't get separated. Just one word about the ordering system. Returning a warranty goods part doesn't automatically order you a new part. You have to call the customer service people and order your new part, and then you send in the old part and we give you credit for it. One other item is, if you need to return the entire unit for refrigeration repair, then here's the procedure for that. You need to call me at the 800 number and get an authorization to return the machine. What that'll amount to is I'll get the machine number, and I may go through the diagnostic chart with you to be sure we have a refrigeration problem, and then I'll send to you a packet that gives you the address and all the details of how to ship the machine back to our depot to get the refrigeration repaired. Normally, refrigeration is repaired and sent back to you in 30 days. The last section of the manual has to do with service bulletins. We've already sent out in the neighborhood of 5 or 6 as different things came up that we felt you need to know. We'll continue to do that in the future, and we'll send service bulletins out as timely and as often as we feel they're needed. And we'll try to get the widest distribution so we be sure and get a copy into your hands. And when we do, be sure and put it in the book because it will contain valuable information.
Well, there you have it. With this video and your Level 2 service manual, you should be able to take care of any problems you might have with the BreakMate, maybe with the exception of the refrigeration system. But any one of our regional service centers can take care of those refrigeration problems. The way we have segmented this video and with the VCR index guide, you should be able to quickly reference any section of the tape and go directly to the area you need to review. Fortunately for all of us, the advanced technology employed with the BreakMate and the quality manufacturing of the Siemens company make our service problems few and far between. In fact, you will want to make sure that you keep busy installing the BreakMate, because if all you have to do is repair it, you might get pretty lonely out there. Thanks for your participation today. Your service support has been and will continue to be a key part of this incredible phenomenon in the beverage business known as the BreakMate. All of us at Breaktime Enterprises and the Coca-Cola Company applaud your efforts. Keep up the good work, and thank you.